Welcome to Lesson 5 of Unit 1. We're coming up to the end of the chapter here, and this lesson is on solving inequalities. So by the end of this lesson, you'll be able to solve and graph the solutions to inequalities, and you'll be able to write those solutions using interval notation. So first of all, we need to talk about some different properties of inequalities. In order to solve them, we have to have some rules to work by. And first of all, we have an addition property and we have a subtraction property of inequality. And here's what those properties say. If we have any real numbers a, b, and c, if we start off with a being greater than or less than b, then one of the things we can do is we can add a number to both sides and it maintains our inequality. So if we add a number c to both sides, the inequality still is true. Here's an example. As long as we start with a true statement, 3 is indeed less than 5. And then if we go ahead and add -4 to both sides, we get -1 being less than 1, which is still a true statement. Same thing holds true for subtraction. Starting with the same inequalities, if we subtract a number from both sides, we still get a true statement. Here's an example. If 2 is greater than -7, which it is, if we subtract the same number from both sides, then it says -6 is greater than -15, which is true. So we can also use multiplication and division properties of inequality. Multiplication and division properties of inequalities. So the negative number, you have to flip your inequality sign, okay? Here's some examples. For any real numbers a, b, and c, if we start with a being greater than b or a being less than b, as long as c is positive, okay, we can multiply both sides by c and it holds true. Here's our example. -2 is less than 3, and then if we multiply both sides by a positive number 4, we still get a true statement. If c is negative, however, okay, if we multiply by a negative number, notice this thing flips, okay? We're multiplying by a negative number, then the inequality switches. So we started with 5 being greater than -1, and now we're multiplying by a -3. Once we multiply by that -3, notice this inequality switched which way it was pointing to give us our true statement. Okay, same holds true with division. Okay, if we multiply by a positive number, inequality is fine, stays the same direction. However, when we divide by a negative number, then that's going to flip it, right? Here's our example. And notice that our inequality flipped because we divided by a -2. So, interval notation, okay, we're going to be using what's called interval notation, and parentheses indicate that the endpoint is not included in the solution. But when you have a bracket in interval notation, that says the endpoint is included in the solution. So the other thing to note is that infinity and also negative infinity always uses a parenthesis because infinity goes forever, so there is no endpoint. So let's go ahead and jump into an example and see what this looks like in action. This one says solve 7x minus 5 is greater than 6x plus 4, and then we're going to graph the solution on a number line. So we solve it just like we do any other equation. Okay, I'm going to subtract negative or add -6x, which is the same as subtracting 6x. So we'll end up with x minus 5 is greater than 4. And then we're going to add 5 to both sides, giving us x is greater than 9. So in interval notation, this says all the solutions are anything bigger than 9. Is 9 included as a solution? Well, 9 is not bigger than 9, so 9 is not included, so it has a parenthesis. Okay, 9 is not included, and it's all the numbers to the right bigger than 9. So here's what that looks like on a number line. It's an open dot on 9, and all the stuff to the right is shaded in. All numbers bigger than 9. Describe each set using interval notation. This says anything that's bigger than -8 is -8 included. There's no equal to with it, so it's a parenthesis with the -8. And that is the left-hand side, right? Everything to the right of that would be included, so it goes to infinity. Now part B here says anything less than or equal to -9. Now this time -9 is included, and it's all the stuff to the left or smaller than. The arrows kind of tell you which direction it's pointing, or all the stuff that's bigger than 1. 1 is not included, so your interval notation will look like this. You have two intervals from negative infinity up to negative 9. It includes negative 9, so that's a square bracket. 1 is not included, and then all the stuff after 1 is included, and it's the union of those two sets. Okay? So hopefully you understand what union and intersection. Union means it's a combination of everything. Intersection means it's what they have in common. So here's a couple more examples. It says graph each solution set on a number line. Well, what does this interval look like on a number line? Well, it has the endpoint 4. It's a closed dot because it's a bracket, and it's all the stuff to the left. So that should look like that. On this one, there's a closed dot on 5 and all the stuff to the left. An open dot on 7, it's not included, and all the stuff to the right. So that's what that graph would look like. This one says solve the inequality, describe the solution set using interval notation, and graph the solution on a number line. So here's our inequality using the math that we know how to do. Okay, we get 13 minus 17x is greater than or equal to negative 4. And then subtracting 13 from both sides and dividing by negative 17. Now notice we had to flip the inequality because we divided by a negative. Don't forget that, or you'll get it messed up. And in interval notation, anything that's less than or equal to 1 is a solution. So we're going to have a bracket around 1 and everything to the left. So from negative infinity, remember all the infinities have a parenthesis, up to and including 1. Well, what does that look like on a number line? Well, a dot means that the point is included, right? Oops, get rid of that. A dot means that the point is included in the solution set. It's a closed dot and anything to the left. Couple of things over here on the left. When solving an inequality, if you get a false statement like this in the end, after you solve it and your variable drops out and you get a statement that's false, 3 is greater than 5, then your solution set is the empty set. The other thing that we usually say, if you want to remember it this way, I usually just write, let me just grab my pen here really quick, no solution. That's totally fine. You can abbreviate it like that there's no solution, or the empty set, either is fine. Just be careful that you don't confuse the empty set with 0. 0 is a solution. So I'd rather you just write no solution so we can keep that clear. If you get a true statement and the variable is dropped out, then in that case what happens is we say it's all real numbers. All solutions work. So no matter what you put in there then, it's the set of all real numbers. So variable drops out, true statement, all real numbers. Variable drops out, false statement, no solution. Here's a couple for you to try. Bring your answers to class, and we'll see you then.